right, let's get this moving. Okay. All right, you are here for the Sometimes Sunday Math Show. And what that's about is it's about basically I'm trying to go deeper into the ideas of math because I am concerned that computation is everywhere, but the ideas behind it are somewhat easy to understand, but they're actually not if you don't like math. So, again, I made a mistake and I didn't press go live, so I was talking to myself for 20 minutes, so I was slightly disoriented. But let me remember what I said. First of all, take a sip of water. Hydration, very important. Okay, so sorry for keeping you waiting. All right, so why does this exist? It exists because I'm trying to draw a connection between this world. These are Canis textile shells. They are quite beautiful. Let me get closer to the camera. Let's see here. Quite beautiful. They are textile shell. They are shells based upon the idea of an idea. Nature didn't do this by intentionally, of course, but there's a computer algorithm that lets you synthesize patterns like this, and it's kind of eerie that it exists in this form in nature. So it's kind of like, to me, a kind of like a connection between math and nature. Quite beautiful. And why is this important? It's important because, let's see here. It's important because we live in an era of speaking machine. And the problem is that there are some people who can speak machine. They're good at math and good at business, and some people who can't. And so it was pointed out to me that why don't you do something about talking to math? Just math, basically. So I thought, oh, I'll give that a try. And I also wanted to learn YouTube Live. So what a better way. So let me first just realize my color is not correct. Again, this is called an experiment. It's called an MVP. So I like to, it looks okay, good. Minimum viable product test. And I'm going to be doing this once in a while. I'm saying sometime Sunday. This is a kind of a side hobby that I have, which is to learn these technologies myself. I see all these gamers and everything online, so I have all this technology now. And I'm excited because I don't know how to use it. So if something doesn't work, just we'll pause for a second and try to figure it out together. Okay, so what is the goal of Sometimes Sunday Math Show? The goal is I'm going to use the product kata method that Melissa Perry uses. She's a terrific product management leader. So what is a target condition? I would like more people to have a math kind of smiley experience. I just want to note that when I was a kid, I probably wasn't as good at writing as I was at math. So that's why I was better at math than writing, maybe. But then my mom was watching. Thanks, Mom, for waiting. Again, I was talking to myself for 20 minutes. But anyways, I'm back. I'm here. I'm here like online. What is the actual condition? I think that a lot of people's first encounters with math might not have been positive because math is fairly abstract and it's kind of like disconnected from, well, it's abstract, so it's disconnected from reality. So some people connect to it, some people don't. So we want to kind of like take people from here to here. Like, this is kind of like, don't care to kind of yay. What was my last step? This is my first experiment at this. This is what I call like a first pancake, which means like no one's watching, so it's okay. And I'm hoping to learn like how this format works. I got my studio set up to work this way, so that was a thing unto itself. So I learned something there. What obstacles impede progress to the target condition? Time. I think time, I can have all this cool equipment, but I can't buy time. So that said, we make time. That's why I made this live. That's why I thought I was live. Oh my gosh, I'm so embarrassed. But I was. So anyways, time, allocate time, lost time, but we'll get it back. What's my next step? I'm going to go through this roughly 15 minutes talking about math, and then I'll stop, and then I'll see what we learned from that. And then, so 15 to 20 minutes maybe, and then just learn what happened. And if it worked out okay, I'll try it again. So we'll see if I iterate. Okay, let's keep a track of this. I'll keep this on my board here so I remember that's what I promised. Okay. And one reason why math is important is because of technology. You know, this is a Samsung 360 camera. It's from 2016 maybe. It's kind of old, but it still works. And what it does is it takes an image from this side and an image from this side. And with those two images, it's able to create one single fused image in 3 dimensions, which is kind of weird. Like, how did that happen? Was it magic? There was no like Harry Potter spell around that. It happened because of math, and math is kind of like a magical spell. Again, it's a bit difficult to walk through the math forest, so hopefully I will be your guide through that. And if I don't do a good job at that, there's this thing called comments that will tell me how I can improve. I believe in radical candor, so if you have something I missed, you wanted me to cover, great. But again, this is the first pancake. It's going to taste bad. It's going to taste bad, have too much baking soda, etc. in it. But we'll get through this. Let's keep cooking. Okay. And why are you watching this? Probably because you're living in the C19 era where you're looking for signal out there. I am. I'm really checking YouTube out, checking all the geographies, seeing how businesses are shifting, changing, and looking for knowledge. I find that knowledge has always existed if you keep looking for it. And this is a great book by John W. Gardner. There's an essay online on pbs.org that I visit maybe once a week. And this book is cool because I can like flip to any page randomly and find some kind of thing that I need for the day. Let's try that. This is chapter 11, Attitudes Towards the Future. Oh my, this is so weird. Onward and upward, question mark. An individual cannot achieve renewal if they, this is written in the era of like non-gendered, like wasn't gender aware, if they do not believe in the possibility of it, nor can a society. At all times in history, there have been individuals and societies whose attitudes towards the future have been such as to thwart or at least greatly impede the processes of renewal. So the whole theme behind this book is that there are some people who are designed to be able to recover fast. There are some who might be often less privileged, who have a much harder time. And there are those who are sort of like in the middle somewhere. But it's a job of people who can keep renewing themselves to find the new path. So if you're listening to this, you're curious about the new path, you're aware of computation, you're aware of the cloud, you're aware of the fact that a lot of your data is being soaked out of you. I'm sure YouTube's having its day here too. But that said, if you understand, you can compete. And to compete is a good thing. And when you can compete, you can renew yourself faster. It's kind of like when I figured out that, sorry, Mom, but I didn't figure this out later. But if you have a Band-Aid on, like a cut, it heals faster. That's kind of a pro tip, right? So knowing those kind of like things about how the body works, how things work, makes you more resilient. And resilient is the key right now. So let's get more resilient when it comes to computation. Okay. What time is it? Let's do 10, 12 more minutes. Okay, let's go. So first of all, how did I think of doing this? I started by looking at the mathematical standards for high school. And I was in the education space for a long time in my life. I was in the computer science education space. I was in the design education space, the art education space. But throughout it, I could see that everyone is gifted in their own different dimensionality. And when you can find that giftedness, like all kind of things open up. But school is a busy place. It's sort of hard to kind of find yourself, even though there's so much variety, which is great. And by the way, teachers make the school, not the educational materials. I know my life was changed by individual teachers who actually noticed me as a human being. So that human part is what gets you to the place that connects you to the thing you actually wanted to do, whether it's your parents, or if you're lucky to have parents who think like that, or your parents' friends, or your parents' friends' coworkers, whatever. Like, that network is so important because those people are the ones who can help you find your path faster. But anyways, I was in the lobby of a swank hotel in Boston one year, and I noticed there was, I think she was maybe 8 years old. A girl was walking around the lobby, and then she said, Mommy, look at this. Look at the shadows. Aren't they beautiful? And I was like, huh. I was working in the lobby. I was already working all remote at the time. And I was working in the lobby. Why was I working in the lobby? Well, I had good coffee. So anyways, she says, Mommy, look at this. And the mother comes over and says, let's go. We got to go. Let's go. So it's clearly she didn't notice what happened with her daughter. So anyways, I checked it out, and there's this glass chandelier, and it's quite beautiful, this chandelier. But it's this gold, it's got colors, etc. It's sparkly or whatever. But she didn't notice this. She noticed this over here. She noticed the shadows that were cast. And I thought it was just kind of a wonderful example of, it's like that Harry Potter, Harry, you're a wizard. I wanted to say to her, whoever you are, you're an artist because you see patterns that no one else can see. And in many senses, that's what people who find the field they want to be a part of have, the gift to understand the hidden dimensions that no one else can see. Like if you're a finance nerd, you're like, oh my gosh, that spreadsheet, amazing. I can just use it so well, and I can find so many patterns. Anyway, so math is about finding patterns that are often invisible, and they're also multi-dimensional. So they're a little different. Like in this case, you can see the pattern and sort of, imagine it. In math, it's all imagining imaginary things and doing it extremely well. And so that's why math is a bit difficult to travel the cognitive distance for some people whose minds may not work that way. But if you can find patterns, then you're going to be fine. Like my mother, I wouldn't say forced me. My mother my mother encouraged me to do word search puzzles. Oh my gosh, word search puzzles. I don't know, maybe she read it in the National Enquirer that word search puzzles are important. Anyways, I am really good at finding words in a word search puzzle because she gave me the gift of pattern finding that way. So you can be a pattern finder in any kind of discipline. But when you're good at math and pattern finding, you get to do special things. Going back to speaking machine, if you work in a tech company and you work in this category of a field called machine learning or artificial intelligence, you're exceptionally good at finding patterns in multidimensional data, working alongside computers and algorithms and things like that. And that's a special gift. And it's a gift that's been enhanced, sort of bionically enhanced by the new types of computers we have available to us today. So anyways, we're all pattern finders in different fields. And math is the art of pattern finding as well. So what I did is I downloaded the math Common Core curriculum for math, and I went through it and noticed that it covers everything from kindergarten to 12th grade. I'm going to assume kindergarten is off the table. We're all good there. But I wanted to start from 8th grade because 8th grade is quite interesting. So let's talk about 8th grade. I'm going to do a little bit of 8th grade. Maybe in the next sometime Sunday, I'll go a little deeper into 8th grade. And then if this is working out okay and I still have time to allocate to this, let's go past 8th grade, shall we? Let's go. All right. So first of all, so this is the high school curriculum, much more exciting perhaps, but let's go 8th grade. And again, I made the mistake of not hitting go live now. So now I know how to use YouTube Live. So very good learning experience for me. Okay, So let's sort of backtrack where I was to share with you what I learned talking to myself. Okay, so first of all, in grade 8, a key thing that is learned is the number system, specifically rational numbers. Now, in 8th grade, I wasn't so sophisticated in thinking of the world in a more like psychological, social science type of view. But when you hear rational, that means something. It means logical. So when you hear irrational numbers, you're like, not logical numbers. So anyways, we have to remember that these terms were made like a long time ago, so they may not make that much sense in the present day. But going back to the speaking machine world, how does this apply? A rational number, we would call an integer. A number that isn't dividable into like smaller pieces like 1, 2, 5. There's no extra detail or fringe around it. But an irrational number is what we would call more of a floating point number, a number with like 5.23 or like 1.62, or that extra bit of subdimensionality. The way to think about it is, I love scallions. So scallions, they got these like green shoots or whatever, and the stringy bottoms, whatever like that. And the scallion, it's like, rarely do you eat like the whole thing. Like that's an integer of a scallion, but you're gonna like chop the scallion really tiny. My dad was a cook, so he's really good at chopping the scallions. And so you might break that scallion into smaller parts, and that's what you would use to have like, 2 scallions, 0.34, like smaller increments of scallions. So it's taking a whole thing, chopping it up. You're going to call it a float number or floating point number in the computer versus an integer, the whole scallion, which, I don't know. Some people go there, but I like mine chopped. Floating point numbers are expensive, meaning, you actually have to pay more. But floating point numbers, to compute them is more work on behalf of the computer. It's changed a lot over time, but integers, whole numbers, are the computer's like, we like that. We like whole numbers, integers. But floating point numbers, not bad, process very quickly today too. There was a time when we did most computing in integer math. Like most of my old work from the 80s and 90s was all done with integer math. It was pretty hard to write it that way. But now, doesn't matter. It's like there's like good glue today to make stuff. So that's old John talking. Okay, next topic is expressions and equations. And I know that I'm slightly dyslexic. So when I first encountered this f of x equals y business, it made no sense to me. I'm like, what's the parenthesis doing there? Like, how is that equal to it? What's this f thing? So even to this date, it creates cognitive dissonance for me. So let's break it down. It's quite simple, really. F is the name of a magic transformer box. It's a name. And the magic transformer box takes an input x and then shoots out a y. Let's use COVID-19 era economics to describe this. So you know how like toilet paper and flour, hard to come by. Flour baking is like way up. I saw the data. It's like, whoa, baking is big right now. Making flour hard to come by. So when you think of F as the magic process to make bread, it's like, let's call it bread. And you think about how bread needs like flour, F, it needs eggs, E, etc. And out comes a loaf, right? So that's kind of like saying bread of F and E equals loaf, right? So technically it's not equals, it's kind of like creating something, but F is the name of the magic box. The stuff in the parenthesis is the stuff that goes into it, and Y, this thing on the other side, is the stuff that comes out of it. Okay, so that's an expression, and it's the foundation of everything you do when you write computer programs. It's super important to understand how this kind of input-output thing works. It's a bit clumsy at first. Every computer language does it differently, which makes it harder. especially JavaScript. Oh my gosh, JavaScript. Keep inventing a new way to do that. But a function is a way to encapsulate a process, but you have to distill it to inputs and outputs. Okay. Geometry. Let's talk about geometry. So geometry, the best way to understand geometry for me is thinking about how the computer cursor is really important, right? The cursor on your screen. And when your cursor is on your screen, it has a position, X and Y, right? X and Y. When you move it around, it changes as well, right? It's over here. X2, Y2, it moved. And so once you have these 2 points, a whole bunch of goodness gets unlocked. You start asking questions like, what's the distance between these 2 points? How far away is it? Because you kind of want to know. You also want to know, did I click a button? Am I inside a rectangle? Or like, am I moving around the screen so I'm kind of like a circle? I think I'm moving in a circle. Or I'm moving in some recognizable pattern. And when you think about it, this whole screen we have here is basically, like this phone here, is basically math class XY grid paper. Can you think about that? That's kind of a little disturbing when you think about that. But your smartphone is basically grid paper, and on it, at any given moment, people who work with computation are figuring out the relationship between the different points, the different shapes, and that's all geometry. That's why it's really important to understand geometry and basic point-to-point relationships, line relationship, rectangular relationships, etc. The 8th grade standard also includes cylinders and things like that. You don't use cylinders a lot unless you're like in the beverage industry, perhaps, to kind of calculate how much like beer or whatever goes in that can. So I think math, a lot of math education has tried to live without the computer for so long. But I think today I see much more contemporary math education involving like real like simulations and things like that. So these were good ideas back when there weren't computers, computing this or like pyramids and things like that. They're cool problems to solve, but they don't actually exist in the real world. But again, it's like working out. It's like stretching and things like that. Okay, last one. Statistics and probability. Let's use this part of the paper. Statistics and probability. What that means is if I have a bunch of points out there in space, it's the art of guessing, like, what the heck is there? Like, what are those points? Like, what are they doing? Like, I don't know what they're doing. It's finding relationships. For instance, if we had, I'm gonna take my pen and I'm gonna like poke it along, like hugged against my phone here. Do you see that? So if you look back, you can see that it's actually on a line. And that's what probability statistics is about. Can I find a line? I can find a line because it really was stuck on there. Sometimes it might be like my hand moving all over the place. And if you find a line, good luck, because it's probably no line in there. But sometimes different patterns coming out of different systems produce patterns, and you can therefore recognize the behavior underlying that made those patterns. And that's what's magical about statistics. It was super hard when we were just counting with our eyes or hands, but with computers, oh my gosh, statistics are amazing. Many math educators now question whether or not in high school learning calculus is important or not compared to learning statistics. Whoa, this could get bad, but it's like this like a Pepsi versus Coke thing, statistics versus calculus. But many people argue that calculus was pushed out as a way to make more people into better rocket scientists. But statistics is a better way to make people who are able to work in this how to speak machine world, this dataful world. So I'm a believer that calculus is beautiful, so we'll go there. But I think statistics is super powerful, especially with computation. And that's how we get to machine learning and things like that that are a little bit eerie and spooky. Like, if you wonder how you found this video by accident, it's because YouTube understands, what you're randomly viewing, finding patterns, and then guessing you want to see this person. So statistics at work. All right. Thanks for listening in. We did our first one. And I might do this again on Sunday. I'll go deeper into 8th grade math, so I'm not like shooting over it. And 20 plus minutes I promised. Back to your day. I'm back to my day too. Thanks a lot.